Gary Fox of Create and Make, and tonight we're going to talk about a LM555 datasheet. The 555 timer has been around for a lot of years. I remember it in the 70s when I was an electronic technician. So it's been around a lot of years. It is an analog chip as compared to a digital chip. So this is really kind of old technology, but it's proven technology. Okay, the data sheet that I'm using is from Fairchild, as you can see, and I will have a link to it. And I'm actually looking at it right now, right off the web, so this is the one that you will get also if you go to that link. The link's right up here, but I will put it on the notes with the video. Okay, first page of it says that it's really good, and it does several different things, and it has, it's just an advertisement kind of information at that point. The big one is that, as you can see, this thing comes in a dip package. It also comes with some surface mount packages. We're going to use the dip for the project that I'm working on. The project I'm working on is basically one that I've copied, and I've got the links to that in my web blog, and I will put those on in the system notes also. Okay, let's go to the second page. The second page has got a block diagram, and that's really good. So let's talk about this. And you'll see that you got this value called VCC, which is the voltage, the positive voltage going into the thing, and a ground. And between that, there's three resistors, which forms a voltage divider. So let's say that VCC is at 15, then we could expect this point right here to be at 10, this point to be at 5, and of course this would be at 0. And that's going to be real important as we consider the rest of what this block diagram does. Okay, here we also have some of the maximum numbers. Maximum number this thing can have is a supply voltage of 16 volts. You see that they'll also, in a lot of their test information, talk about a supply voltage, which is VCC, of 5 volts. But as we look at that, we see that we've got these two things that look like our op amps, but they don't have any feedback resistors. And those are basically work just like an op amp. They're a voltage comparator. And it says that if the positive voltage is greater than the negative voltage, then it would output a positive value. And if the negative is greater than the positive, it would go down to 0. And that's like an op amp without feedback. So we can know that this threshold and this trigger are inputs to this chip. We got this value here called control voltage, which is pulled at 2/3 of the VCC voltage, because these R values, we can assume that they're all the same. And so that right there is going to be one that we have to deal with sometimes. We have an output, it has an output stage, and so it's going to amplify the output and give it a little bit of more current. And somewhere here at the top it said that it can supply up to 200 milliamps, which is quite a bit of current really for a chip. And then we got these two transistors, which is why I talked about transistors in a couple of recent blogs. Okay, on this one, this value called reset is going into the base of that transistor. And you'll see that that's a PNP transistor. So this will be forward biased when this reset goes low, goes less than what VREF is. When it goes low. When it goes high, greater than VREF, it will be turned off. The transistor will be turned off. So we know reset's an input. We see right here we got this thing called discharge, and it's coming off of the collector of a transistor. That particular transistor is NPN. So that means the discharge, when this thing turns on, discharge is going to be pulled low. Okay, we got one final device here that's labeled FF inside this block, and that stands for flip-flop. Okay, a flip-flop is basically an electrical version of a toggle switch. Or a toggle is the mechanical thing, and a toggle switch is what we're all used to. So you think about your wall switch. You used to turn on your lights in your house. It's either on or it's off, and once you flip it in one position, it stays at that position until you flip it again. So we've got these inputs going into this thing. We got two outputs, but we got these inputs, and we expect those to do something to that flip-flop. And those are going to be real important on what they do. So how are we going to find out what that flip-flop, what triggers it? Well, as we go down here, first let's go to this page right here, which is on page 4 of the data sheet. The reset pin, if it goes low, then it says it doesn't matter what the threshold or the trigger pin do. So it's always going to stay at a low output, and the discharge transistor is going to be on. So reset basically is a override button. It says while reset is low, nothing's going to happen, and that's what the usual purpose is for a reset on a flip-flop, is that its purpose is to turn the flip-flop off in its reset condition. Okay, once reset's high, then funny things happen here. And if the trigger, pin 2, and let's make sure that I'm reading TR right. We'll go back up here. Pin 2 is called trigger. So we'll go back down here. And when we go to trigger, if it's less than 1/3 voltage, then it causes the output to go high, and it causes the discharge transistor to go off, to get turned off. If it's greater than 1/3 and the threshold is greater than 2/3, then the output voltage goes low, and the discharge transistor goes high. If the trigger is greater than 1/3 voltage and the threshold is less than 2/3 voltage, then it stays at the previous state, whatever that was. Let's go back up here and see why they say 2/3 on the threshold and 1/3 on the trigger. If we look at this trigger, is looking at the voltage divider at 1/3, so that's where the magic's going to happen at it. And the threshold is looking at the voltage divider at the 2/3 point, so that's where the magic's going to happen with it. So that's why they use those numbers. So you don't necessarily have to look at that little chart, and then you remember that the reset just holds it turned off. But the chart's helpful. Okay. Now this chip can be operated in several different modes. And we're going to talk primarily about the monostable operation and the, let's see, I think I done went too far. Monostable, and then later on they talk about astable operation. And that's the two modes where it's doing its timing functions. So we get into these other ones down here, which will probably be the next post, the next video. It's basically modifications of those two right there. Okay, in the monostable mode, basically the trigger is an input coming from the outside world, And then what you have right here, you have an RC network between RA and C1. And as C1 starts to charge, once it gets above that 2/3 point, it triggers something inside this thing that causes it to turn off. Once it stays turned off, nothing happens until that trigger is turned low. And then the trigger starts it stays in that high mode until it gets to that point where it charges again, and then once it charges, it turns itself off. The reason it's called monostable is it's only stable in one condition. When you trigger it in the other condition, it's in a temporary mode. So everything happens based upon what this RC network is, how it charges. And you see that you basically have the log formula, exponential formula, causing this thing to charge. And so as you pick this RA and the C1 value, you can choose how fast that thing's going to stay before it triggers back to its normal mode of it being turned off. Let's zoom up on this thing just a little bit so we can see it a little bit easier. And you'll see that they have this chart here that tells you how many seconds it'll take, depending upon the capacitor and what the resistor value is. You can choose that to come up with the amount of time that it's going to take. If you go through this words right in here, as it describes the operation, it goes into some actual formulas. It also says that some bad things can happen if you have this thing triggering too fast. You want it to trigger slower than what the time is for the thing to charge up and trigger itself. You can cause these kind of fake discharges going on there. So anyhow, that's basically how that works in the monostable mode. Let's see how we are on time. Okay, I'm about 12 minutes into this thing, so I think we'll wait. We'll talk about the astable mode in the next video, and then we'll deal with a little bit of the charts up there, talking about the values that this thing can do. I appreciate you listening. Hopefully you got something out of this. There will be a second video, probably a third one also, but there's more to come. Thank you.